let's think about the firm supply function now. So let's think about the problem of how much stuff the firm supplies given prices. And what can we leave my notes here. So what can we say about firm supply given the marginal cost function? Yes, Chris. Yes. I mean, it is less than 1. I'm not going to say it there, though. I think it's, since we have the other cases written out there, I'm going to not regard that as an error, but rather as a concise expression of what I'm trying to say on the graph. Okay, so we want to consider firm supply. So think back to, again, an intro course. What are the axes for when we think about a supply function? What's the space range? So, yeah, okay, and which goes, so we got, I'll say prices and output, so what goes on which axis? Okay, so again, we have Alfred Marshall to think about this. But yeah, we'll have when we think about supply, we'll put P up here, and we'll put Y here. And we want the supply function just gives us the connection between prices the firm faces and the output it chooses to produce. Okay, so, but that's what we just drew. We just drew a variety of functions in that space. So Y up there, because, remember the first order condition, is that a competitive firm has dC dy equal to P. Okay, so we can take exactly these marginal cost functions and just treat them. They're formally the firm's inverse supply curves, and they're just the firm's marginal cost functions. So we've got prices here, we've got Y here. We might have a supply function, like I think the last one I drew here, with alpha 1 plus alpha 2 greater than 1/2 and less than 1. So that might be a reasonable firm supply function. Or I should say inverse supply function. Is that clear? Is it a little... So we're using the first order condition to notice that for the competitive firm, prices are equal to marginal costs, and we just characterize marginal costs as a function of output. So that means we can draw the inverse supply function. Is that clear? Is it obvious? Yes. Yeah. No, I mean the axes are shifted. You know, the firm supply. Well, this firm supply function is this is the answer to the question: how much should the firm produce given the prices it faces? So that's something that has units of output Y and depends on P. Thanks to Alfred Marshall, so we had the same problem we had on the demand side, which is that Marshall got the axes backwards. So we're going to put the variable that the firm takes as given on the vertical axis and the firm's choice on the horizontal axis, which is just a little odd, but we're stuck with it for historical reasons. Okay. So formally it's not a supply function; it's inverse supply function when we have it turned around that way. Okay. All right. So we've already computed. I mean, so that means that we've computed for this example the firm's inverse supply function. It's just this. Price is equal to this quantity here, so that's the firm's inverse supply function, and we know that about firm supply. Okay, which is what this slide says. Okay, so I want to forge ahead here. So we got the inverse supply function. It actually is, which is what we want for graphing it in this sort of Marshall space. And here's a picture of it, not so different from what I drew. We also want to be able to get the inverse supply function now. And so hold on, I want to go back here and go ahead and work out for you what the firm supply function, not the inverse supply function, but the firm supply function looks like. So to do that, we have the inverse supply function here or here, depending on how you want to do it. To get firm supply, that is output as a function of prices, we just need to invert this function. So that's not difficult. It does involve a little bit of algebra, so I'll go ahead and do that algebra for you. Okay, so we're going to start with this same thing. Prices are equal to dC dy. That's the first order condition for the firm's optimization problem. And for this case, we know that this is just equal to 1 over alpha 1 plus alpha 2 times C YW over Y. So I'm just using this along with the fact that prices have to be equal to marginal costs for a price-taking firm. And I can simplify this just using this. So this in turn is equal to this. Write it this way. Okay, so that's the marginal cost function, all equal to P. Now what I want to do is to invert this thing. So I'm going to divide by H alpha. I'm going to divide by these prices here. I'm going to multiply by this A raised to the appropriate power, multiply by this. And to make a tedious story short, what we get, if my algebra is correct, is Y equal to alpha 1 plus alpha 2 divided by this constant alpha. So this whole thing now just depends on the alphas. Times A divided by W1 to the alpha 1, W2 to the alpha 2. This whole thing raised to the 1 over 1 minus alpha 1 minus alpha 2. All times P raised to the alpha 1 plus alpha 2. This is all raised to its power. 1 minus alpha 1 minus alpha 2. Okay, so here's an expression now for the firm's supply function. Is that clear? This notation is a little bit weird. This is P raised to this power, and it's multiplied times all this other stuff. Okay, so something that's sort of worth noticing about this, if we're thinking about how supply depends on output price P, we can rewrite this thing a little more compactly. And just write it as Y equal to, I'm going to give this thing a name, by the way, F of PW, which is what I'll use for the supply function. It'll be equal to P raised to the alpha 1 plus alpha 2, 1 minus alpha 1 minus alpha 2, all times a function that depends on just the alphas and the W's. So let me just call this a function H of W and alpha. Okay. And so the inverse now has, so the regular supply function, the inverse of the inverse supply function, has P here and y here. And where we had the inverse supply function before with y and p, and it looked like this, this one will look like something like this, just the inverse of this one. Okay, so we've got the firm supply here. We know in particular how to express y as a function of just prices and these alphas, so a function of p and w and the alphas. Yes, sure. Uh-huh. Yeah, because it's the inverse, yeah. Is that the question? Yeah, so... Oh, I see what you mean. Sorry, yeah, sorry. I should copy that one, I agree. So let me do that instead. You saw I still have it up there? I think not. It can go either way. It depends on whether alpha 1 plus alpha 2 is greater than or less than 1/2. Go back to that case. If I'm going to copy what I did there, this is just point I should do this, and this will be this. But all we're doing is, whatever the shape of this thing, we're just figuring out, we're just inverting it, okay? Okay. All right, so I want to do one more thing before I let you go. And that is to consider what we probably started with, which is firm profits. So we've characterized the firm's cost function as a function of output and prices. Now we figured out what firm supply is as a function of just prices. And so now we can do something pretty cool, which is to figure out what profits are just as a function of prices. So here's this expression I just wrote, and here are going to be profits. Look, we know that profits are equal to price times output, but we solve for output just as a function of prices now. And we know what costs are as a function of output and prices, but again, we solve for output. So we can substitute f of pw for y, both in the cost function and also on the revenue side. And that's going to give us an expression for profits that, look, the only variables that show up here are prices, p and w. Now let me, I guess, whoops, what did I just do? I don't know what I just did. There we go. So let me go out in a quick flurry of algebra here by working out the profit function for our common Douglas example. And so yeah, let me do that next. So we know that we have this. Oh, I did it for you here. That's nice of me. Okay, so we've got the supply function written out. This is what we had before. Here are profits. So here's an expression for profits. Let me go ahead and do the algebra because I don't think that's obvious, and also gets a little bit simpler. Actually, maybe I'll take a poll. Who wants to see the algebra to get to this line? And who wants to leave 5 minutes early? Is there a demand for is that Lee? You see the algebra? Okay, fine. All right, so it's let's see how it goes here. So we've got an expression for the supply function. Profits here are equal to pi times that supply function. I'm going to write out the compact version of that for a moment. So I'll have p times p raised to the alpha plus 1. I'm sorry, alpha 1 plus alpha 2 over 1 minus alpha 1 minus alpha 2. So we got that there. Times this function h of w alpha that I defined a little bit ago. So that's p times, right, this is just f of pw, that's the supply function, minus the cost function, which is c, evaluated at the same f of pw. So it'll be p to the alpha 1 plus alpha 2, 1 minus alpha 1 minus alpha 2, all times this function h of w alpha, w. That's the cost function. Okay, so that's what we've got. Now I just need to do some simplification here. I've got this p adds 1p to this. So that's going to give me p raised to the 1 over 1 minus alpha 1 minus alpha 2. Right? Everyone with me on this next one? This thing, because I'm going to add 1 to this, so I get this, I believe. And times this h w of alpha function. And then here, in the cost function, I've got an expression up there that involves w1 to the alpha 1, w2 to the alpha 2, all over a raised to the 1 over alpha 1 plus alpha 2 power times h to the alpha. This, in fact, is just equal, though, to alpha 1 plus alpha 2 times this function h w alpha that I've defined, I believe. And this will be times y raised to the 1 over 1 plus alpha. But, of course, y is equal to this. So I'll have p to the alpha 1 plus alpha 2, 1 minus alpha 1 minus 2, times h of WA, this, all raised to the 1 over alpha 1 plus alpha 2. And am I done with the cost function? I think I am. Yes.
On the top line, it says h of w alpha. Right?
Yes.
And then on the bottom line, it says now it says get at w comma alpha again. Below that, now you have w comma
That doesn't quite raise a for alpha. My messy alpha doesn't quite count as an error. Yeah, no, there's no intent to change it there. So this h is the same as this h, though. So what can we do? It means we've got an h here, we've got an h here, so it looks like we might have some opportunities to factor that out. We have a piece of h here, that is h raised to the 1 over alpha 1 plus alpha 2, and I think I better stop there and let you go on to your next class. So, thank you.